Sir, thank you so much. Thank you so much, sir. Good evening. Good evening, sir, and good evening to Arvind, sir, and to
Good
all the
evening. Good
respected
evening.
teachers and students who are here. So here we all are gathered here to know more about the eminent scientist C.V. Raman. Yesterday, we celebrated the 136th birth anniversary of the greatest physicist, that is Dr. Chandrasekhar Venkata Raman, who is the first Asian to receive the Nobel Prize for Physics in the year 1930. So in the year 1928, C.V. Raman wrote himself into the history books by discovering the evidence of the quantum nature of light that came to be known as the Raman effect. Uh, I think I'm sharing the screen. Just tell me if is my screen visible to all of you?
No. Yes.
Yeah. Am I audible and visible? Is my
Yes,
screen
Rani.
visible?
Yes, ma'am.
Okay, thank you so much. So we all know that the day of discovery, as A.K. Sharma sir has already said, that the day of discovery, that is the 28th February, is celebrated all over India as a National Science Day. So over the next 1 hour, we are going to have the look at the great scientist's life and his enduring impact on science and the development of scientific temper in India, and of course, his path-breaking discovery. So Chandrasekhar Venkataraman is popularly known as the inventor, the scientist, and the explorer. Chandrasekhar Venkataraman was born on November 7, 1888 at Tiruvannaikaval, 5 kilometers north of Tiruchirappalli in Tamil Nadu, in a middle-class family of scholars and music lovers. His father was Chandrasekhar Ramanathan Iyer and his mother was Parvati Ammal. He was the second child of the 8 children born to Chandrasekhar Iyer and Parvati Ammal. His father was a lecturer in mathematics and physics in the college, which significantly influenced Raman's early interest in science. He was named Venkataraman after the Lord of Seven Hills in the sacred shrine of Tirupati, and by South Indian tradition, Chandrasekhar was his father's name, so his name was subsequently shortened from C. Venkataraman to C.V. Raman. Raman grew up to be one of the most meritorious students of his time. At an early age of 11, he stood first in the matriculation examination. Then he joined the Presidency College of Madras, where his father was a lecturer. Once again, Raman bagged the gold medal in the year 1904 in English and physics. In those days, when India was under the British rule, the brilliant boys went to England for higher studies due to lack of facilities in the country. Raman was also advised to do so. But doctors found Raman's health not strong enough to face the rigors of English climate. So the young Raman happily took admission in the Madras College. Uh, he has taken the course of physics in the Presidency College of Madras, but Raman never attended the physics class, since his teachers had full confidence in his abilities. Now, instead of attending classes, young Raman used to perform experiments in the physics lab of the college and used to write research papers, which was sent to the reputed British journal Philosophical Magazine. The journal promptly published young Raman's first research paper on light when he was hardly 18. Subsequently, Raman used to send more of his findings to the journal and they were published. When he wrote to the eminent British physicist Lord Rayleigh, the latter took him to be the professor and wrote back addressing him as Professor Raman, unaware that he was just a teenage college student. After he excelled the MA examination, young Raman was insisted by his father to join the financial civil service of the British government. The doors of the Indian civil services were closed for him because in those days, entrance examinations were held in England and Raman could not go there due to the health conditions. His elder brother was already in the civil service. So, as a brilliant student with no scope for research in physics in his country, had to follow his brother's footsteps. In the meantime, Raman got married to Lok Sundari, and she turned out to be a modern Sita, a devoted wife who believed that she was born with the sole purpose of serving him in his great endeavors. They had two sons, Chandrasekhara Raman and Radhakrishnan Raman, where Radhakrishnan became a well known astrophysicist and headed the research institute that Raman later set up in Bangalore. At the age of 19, Raman, along with his wife, moved to Kolkata, the then capital of British Empire, and joined the office as Assistant Accountant General with a handsome salary of rupees 400. Kolkata was then the most suitable place in the country for any Indian aspiring to become a scientist. And the young Raman did not want to lose that golden opportunity. It is said that chance favors the prepared mind. Young Raman was so keen to conduct scientific research that it was while traveling in a tram from his residence to the office, he saw the board of Indian Association for Cultivation of Science, and Raman expressed his desire to conduct scientific research in the laboratory of the association during his spare time. And Ashutosh De, who was the caretaker of the laboratory, welcomed him, and thus began the Raman's research work as an amateur scientist. Raman first began his scientific research on sound. He designed innovative experiments to study how Indian musical instruments like mridangam, tabla, tambura, veena produce musical notes. He became interested in the acoustics of some whispering galleries like the Gol Gumbaj in Bijapur. Now, his research findings began to appear in the British science journals, and his name became well known in the scientific community of the West. Soon, research in chemistry and biology also began in association, and Raman received national and international recognition. Raman's scientific research and lectures impressed Ashutosh Mukherjee, the Tiger of Bengal, who was primarily a mathematician and was a vice chancellor of Calcutta University. For the Pilot Professorship of Physics, he gave the first offer to Raman, who was working in the British administration and had no qualified degree like a PhD in research. The Pilot Professorship offered rupees 600 only per month as salary, while Raman was then drawing a handsome salary of 1100 in the British administration. A reduction by rupees 500 per month, almost half the salary, would have dissuaded any other person from opting for a teaching cum research career, but not Raman. He immediately accepted the offer and gave up his secure government job to continue his research work in physics, which was his passion. However, one condition of the Palit professorship carried Raman's way, as the selected candidate was expected to have foreign experience. But unfortunately, Raman did not have. Ashutosh Mukherjee suggested Raman should go abroad for a short while before he resumed duties in the college. But Raman calmly refused. Like a true patriot, he said, he was proud of his independent work in India. And in his blunt style, he said, if given a chance, he was willing to train the foreigners in his own country. Ashutosh Mukherjee appreciated Raman's patriotic feelings and removed the condition for him. Thus began Raman's full-time career in scientific research. Later, in 1921, Calcutta University became the first among the several universities to award him the doctorate degree. In 1921, Ashutosh Mukherjee forced Raman to visit England as a delegate of Calcutta University to the Congress of Universities held at Oxford. During this visit, he gave lectures at various forums on his research and met several contemporary eminent physicists like Lord Rutherford, J.J. Thomson, William Bragg, and visited and worked in the best laboratories there. It was during his return journey from England on the ship SS Narkunda. The deep blue color of the Mediterranean Sea attracted his attention. Why was the sea so blue, even while the sky appeared to be dull and gray? His initial observation of the sea and sky puzzled him as he wondered whether the widely accepted theory about the blueness of sea was correct. The eminent British physicist Lord Rayleigh had theorized that sea was blue as it reflected or scattered the blue light of the sky. Appears to be unconvincing for Raman, as the same water appears to be transparent when taken in a glass. Raman wrote his observations and prepared a small research note on his novel findings. And when the ship embarked at Mumbai port after some days later, he first hurried to the nearby post office and dispatched his research note to the most prestigious science journal, Nature. Such was the passion for the research in Raman. For the next 17 years, he and his students conducted a series of experiments which eventually led to the discovery of what is today known as the Raman effect. Raman's early research interest focused on the behavior of light as it interacts with matter, resulting in the change in the wavelength of the scattered light. When a monochromatic light passes through a material, most of the light is scattered without any change in energy. That is Rayleigh scattering. However, a small fraction of light is scattered at different wavelengths, which is due to the interactions between the light photons and the vibrational or rotational energy levels of the molecules of the material. Raman suspected that there might be other forms of light scattering beyond Rayleigh scattering, and that could account for the certain observed phenomena. This hunch, fueled by the relentless curiosity, ultimately led to his most momentous discovery. So you can see here how Raman is exploring the Rayleigh scattering, where the sunlight getting dispersed into 7 colors with different wavelength, where the violet color having the least wavelength and red color having the maximum wavelength. So violet color having the least wavelength was dispersed more as
તો પેલું લીંબુ વાળું પાણી પીવડાવી ના પાવડર બી ઓઆરએસ પાવડર બેટા એક પાવડર ખાણ ફકાઈ દે.
Okay, now children, you can see the experimental setup of Raman. A monochromatic light source provide a high intense light of single wavelength. Raman used the sunlight as a light source. Later on, it was replaced by mercury arc lamp. He used transparent materials such as liquids, crystals, and gases in small glass container. And a simple lens was used to focus the light from the mercury lamp and to select a specific wavelength from the mercury lamp. Raman used colored filters to isolate the strong green spectral line. Raman and his team used telescope to observe the scattered light, and the positions of the scattered lines were noted, indicating change then corresponding to molecular vibration. A spectrometer was used to analyze the scattered light. Now let us look at the video of the principles behind the Raman effect.
Understand and let us first understand the Raman effect. When a sample is exposed to a monochromatic invisible region, the sample absorbs light, and a major portion of the light gets transmitted through the sample. However, a minute part of the light is scattered at right angle to the incident beam. The incident light is a particular light has the frequency same as the incident light, and the scattering is called as radiant scattering. However, it has been observed that about 1% of the total scattered intensity occurs at frequencies different from the incident frequency. This is called as Raman scattering. Raman scattering can be thought of as two-photon process. The electrons have different vibrational levels. They are defined by specific energy differences. When an incident monochromatic light interacts with an electron in the sample, the electron absorbs energy from the incident photon, and it rises to a virtual state of energy. Energy transferred is given by the formula E equals h nu, where nu is the frequency of incident photon. The electron then falls back to an energy level by losing energy. If the energy lost equals to the energy of incident photon, the electron falls back to its initial level. And in this process, incident photon, the released photon has same frequency as the incident photon. As the frequency is same, Rayleigh scattering occurs. However, sometimes electrons, when losing energy from the virtual state, can fall back to a different vibrational level. In this case, the energy lost by the electron is different than the energy absorbed from the incident photon. As a result, the photon emitted by the electron has energy different than the incident photon. This is possible when the frequency of the emitted photon is different than the incident photon. This gives rise to Raman scattering. Depending upon the final energy of the electron, or final vibrational level of electron, Raman scattering can be separated into Stokes line and anti-Stokes line. If the frequency of scattered photon is less than the frequency of incident photon, Stokes lines are observed on Raman spectrum. This happens when the electron absorbs energy. Similarly, when frequency of emitted photon is greater than incident photon, anti-Stokes lines are observed. This means that energy is released by the electron. The Raman spectra gives the molecular fingerprint, and it is different for different molecules. By studying the spectra, one can identify the rotational levels and thus a particular molecule. This helps in performing qualitative analysis. This can be done. Thus, Raman spectroscopy can be used to perform both qualitative and quantitative analysis on a sample.
So, children, Raman's discovery showed that the light could exchange energy with the molecules, revealing the detailed information about the molecular structure. The Raman effect provided a new tool for probing the molecular composition of substance. Soon it dawned upon Raman that he had discovered a novel natural phenomena occurring in light when it travels a liquid, and that a report on this discovery titled A New Type of Secondary Radiation was published in scientific journal Nature. After the discovery of the Raman effect and its easy acceptance by the Western scientists, Raman was very confident of winning the Nobel Prize. In fact, he would eagerly look forward to the next announcement of Nobel Prizes over radio or in the newspaper. Perhaps he knew that he had been nominated for the Nobel Prize, and in fact, in 1930, he was awarded the Nobel Prize for Physics. When the news of the Nobel Prize reached India, the entire country erupted with joy. It was a major international honor for an Indian in science at the time when India was a British colony, and Indians were not capable of such scientific achievements. Moreover, every Indian felt proud of Raman's achievement because he had made a scientific discovery on Indian soil using equipment worth hardly 200 rupees. When in those days of the British rule, science was considered the exclusive domain of Europeans. Overnight, Raman became an Indian hero, and interest in science among the Indians began to grow. During the Nobel ceremony at Stockholm in December 10, 1930, when Raman was awarded the prize, tears rolled down his eyes. When he was asked later that why he wept, Raman said that he regretted that he had won the prize under the British flag Union Jack. Now, in his own words, I quote, when I sat in that crowded hall and I saw the sea of Western faces surrounding me, and I, the only Indian in my turban and close coat, it dawned on me that I was really representing my people and my country. I felt truly humble when I received the prize from King Gustav. It was a moment of great emotion, but I could restrain myself. Then I turned round and saw the British Union Jack under which I had been sitting. And it was then that I realized that my poor country, India, did not even have a flag of our own. Yeah. And it was that triggered off my complete breakdown. This shows that he was a true Indian patriot and a scientist. When this Nobel laureate returned to India, he received a congratulation telegram from Mahatma Gandhi, who was a good friend of Raman, which dismayed the British Empire. Raman was honored. Raman was honored for his research work. Some of his honors are: in the year 1929, he got Knight Bachelor, knighted by the British government for his scientific achievements. In the year 1930, Nobel Prize in Physics awarded he was awarded the prestigious Nobel Prize in Physics for his discovery of the Raman effect, which revolutionized our understanding of light scattering. In the year 1954, Bharat Ratna, India's highest civilian award, bestowed on Raman for his outstanding contribution to science and national development. In the year 1970, C.V. Raman Medal, which was established by the Indian Academy of Science to honor individuals who have made significant contribution to physics, a lasting testament to Raman's legacy. In remembrance of his great scientific work, Raman Effect, every year, 28th February, is celebrated as National Science Day. Today, Raman's effect is considered to be one of the four major discoveries in experimental physics of the early 20th century. Raman's spectroscopy has become a powerful tool in analyzing various media in industries, pharmaceuticals, biology, remote sensing of pollution, and even nuclear fusion. Let us look at this video.
In 2013, a team of scientists from the Harvard University and the University of Michigan reported a new weapon in the battle against brain cancer, an imaging technology that makes brain surgery dramatically more accurate by allowing surgeons to differentiate level. The scientists used the stimulated Raman scattering or SRS microscopy on mice. SRS works by shining non-invasive lasers into tissue. The spectrum made by the weak signals help in building images of the cellular makeup of the tissue. It would show the tumor in blue colors and healthy cells in green, which allows surgeons to excise the tumor accurately.
I think it is used in medicine, it is used in surgery, detection of cancer cells as opposed to healthy cells, even in satellite sensing. So its applications are very widespread.
Raman spectroscopy is used in many varied fields where non-destructive, microscopic chemical analysis and imaging is required. It shows the chemical composition and structure of any sample, be it solid, liquid, gas, gel, slurry or powder, helping to identify substances in fine detail. Most commonly, we see the uses of Raman spectroscopy in airports and metro railway stations, where Raman spectroscopy can identify dangerous substances like improvised explosive devices. Security experts call Raman scanners the best devices to detect explosives carried by terrorists. Raman scanners are used by narcotic squads and airports to detect drugs too. Safety inspectors are using Raman scanners to detect hazardous chemicals and gases. Police forces are using them for forensic work. Researchers have incorporated the Raman effect on silicon. Because of its crystalline structure, the Raman effect is 10,000 times stronger in silicon than glass.
Many spacecrafts made by any other countries carry Raman spectroscopy. Remote sensing, Raman spectroscopy is used. When you want to find whether a material is adulterated or not, you are using Raman spectroscopy. So Raman spectroscopy has become an essential instrument today. So 50 years, many years have passed by the time Raman discovered this effect and got his Nobel Prize. But even today, the technology that came out of his research is still a very important tool for today's research development and work.
The most common applications of Raman spectroscopy include quality control in pharmaceutical industry and in medical diagnostics as well. Raman spectroscopy is a valuable tool to analyze highly complex materials like biological organisms and human tissue. It is used in geology and mineralogy for mineral identification and behavior. Raman spectroscopy is fast and non-invasive. That makes it a perfect technique when time is limited. Identifying the chemical composition of a substance typically requires chemical and physical tests that take time, but Raman scanning can take just 20 seconds. The spectrum of Raman scattering contains so much information about a sample's structure and composition, it has been described as a characteristic fingerprint. Hundreds of papers are written each year as physicists continue to tweak this powerful technique for new
Discovery
applications.
of water on moon by Chandrayaan was also because of the Raman spectroscopy. In the year 1933, Raman became the director of Indian Institute of Science in Bangalore, where he set up a new department of physics and also set up Raman's Research Institute at Bangalore, which at present is the most active science bodies to conduct several scientific activities. From the very beginning of his research career, Raman felt the need of an Indian journal, Indian science journal, to which he and other Indian scientists could send their latest findings and get published. And this idea took into shape as Indian Journal of Physics and Current Science. His values offer a powerful lesson for the students and for us as mentors. Passion for knowledge, Raman's curiosity and love for science drove his discoveries. We as educators and mentors should teach the students the value of life, the value of lifelong learning and the joy of exploring new ideas. Despite of the limited resource and initial setback, Raman persisted in his research. As teachers, we should teach the students the importance of resilience and not giving up in the face of challenges. Simplicity and humility is also defined as a powerful lesson given by C.V. Raman. Despite of his immense contribution to science, Raman remained humble. Students can learn to stay grounded and appreciate the value of humility even after achieving success. Very rightly said by Dr. C.V. Raman that the true wealth of the nation does not lie in its stored up gold, but the intellectual and physical strength of its people. This saying is deeply reflected in his own life, in his own values, and also in his contribution. Thank you.
Thank you, Rani. Anyone who want to ask anything? Thank you, Rani. You have done beautiful research with the topic. And
yes, well done, well done. Yeah,
so many things, so
so
many things.
very exhaustive. Especially the
Thank
choice of videos has been very nice, remarkable.
Very nice.
Right.
Thank you, sir. Thank you
Yes.
so
So,
much.
anybody
Well
who
done.
want to ask any question? Okay. So now I request Shri A.K. Katiyar ji to please give her presidential remarks.
Yeah,
Please.
yes, at the outset, I thank you, Dr. Sharma and Bharti Vidya Bhavan organization, right, to give me this opportunity to be with you this evening. And thank you, Rani, Miss Rani,
Thank you.
for a beautiful coverage, starting from Sir C.V. Raman's childhood till the biggest achievement
Thank you so much,
and
sir.
his contribution and his
Thank you,
sentiment
sir.
for the country, right? And I would only, like to share one thing in my personal experience first. Now, way back more than 5 decades ago, when I was in college at Kanpur, Sir C.V. Raman has visited. And while addressing the students, and I was an undergraduate student, and some of them asked, one of my friend asked, "Hey, sir, do you believe in God? What religion you believe in?" So you know what answer quickly he gave? He said, "Science is my religion." That is the answer he gave. And uh, another thing, when I visited during my tenure at Moscow, that is when I visited Moscow State University. That was way back in 2006, and the fellow there in the physics department, he took me to the room where a bulletin board was there with old rare photographs. And I was happy to see Sir C.V. Raman's picture there, photograph there. And you cannot imagine, as an Indian, and when you just see the person being uh, rather remembered outside the country, your happiness has no boundaries. Then you feel so happy, right? Now, coming to the next point, in the sense, thus, what happens in the classroom as a teacher, this is a big challenge. And irrespective of the discipline you come from, but the basic things, what we see in the children is this: there is a complete lack of sense of wonder. Children don't, I mean, they only recite nursery rhyme, twinkle, twinkle, little star. But in actual sense, they don't have a sense of wonder. You present something before them, carry out a demonstration, right? Tell them something about the stars, about planets, how Earth rotates, and size of sun, and the distance of faraway planet in our solar system, size of galaxy, and all that. It doesn't thrill them. I mean, hardly there is a sense of wonder, uh, and that is a big challenge. Maybe the web media, the resources, children already know it. So, and therefore that sense of wonder has gone. Similarly, curiosity, their children are becoming less and less curious. And another challenge is that is how to enhance the observation skills of the children. Because Sir C.V. Raman, while on his return voyage, the question came to his mind was, hey, how come the sky is, the ocean water appears to be blue and sometimes bluish green? And if you just throw open this question to everybody, to many people, they will all say this is a reflection of the sky because the sky is blue. People will say that. And Raman didn't agree with that. And that's how it led to this kind of further experimentations. And this Raman's effect came in as a conclusion, outcome of that. And anyway, you have covered the video in which I was wanting to say that, okay, look at the widespread applications of Sir C.V. Raman's effect. And this, the very effect, has decoded molecular structure. And this has lot many applications in diagnosis, as you have covered in that video, and designing the molecules, new molecules for the treatment of most rare diseases like cancer. Cancer has many variations, right? So once you identify what kind of molecule is going to affect that, to cure that, target that cancerous cell, and unless you know that the structure of molecule, you cannot design it, you cannot manufacture it. So that has to be appreciated by the teachers. And once the teachers have these things, sense of wonder, curiosity, and observation, good observation skills, obviously you'll be able to transfer it to the children. So this is, as a teacher, I always felt, even now at this age, I feel to play with the children that way, telling them about the vastness of universe and the smallness of this world, microscopic world, what we call subatomic world, and That is the thing. So that is what our concern is as a teacher, how to bring in the sense of wonder and curiosity and intense observation skills. So thank you. I have heard your, it's once again, thank you so much for your good coverage. And thank you, Dr. Sharma, for giving me this opportunity to be with you.
Thank you, sir. Thank you
Thank
very
you so
much
much,
for
sir.
joining.
Yeah.
Thank you, A.K. Sharma, sir.
It is a wonderful opportunity
Yeah.
to know more and more. And Rani has done a wonderful job.
Yeah.
Thank you
So
so
well
much,
done,
sir.
Rani.
Thank you, sir. Thank you so much. Really, thank you
Now,
for giving me a chance to speak about such scientists. And really, it was a good research work. Even I came to know a lot many things, which I think as a teacher, I can imbibe those qualities in me, which is going to be very, very helpful for my students. And really, C.V. Raman is really an ideal, I can say he's really an ideal teacher and really uh, a very good mentor for his students and of course for each one of us.
so and thank you very
Thank you,
much
A.K. Sharma,
for all
sir,
the
for
teachers.
giving me this opportunity to do this research work. Thank you, sir.
Thank you, all the teachers who have joined us, all the children who have joined us. And in the last, we are coming to the last phase of this, and that is we are finishing it with the Shanti part. And let us see if it is there. Otherwise, I'll recite, no problem. Om Deo Shanti Prithvi Shanti Rapa Shanti Roshadaya Shanti Vanaspataya Shanti Vishwe Deva Shanti Brahm Shanti Sarva Brahm Shanti Shanti Deva Shanti Sama Shanti Redhi Om Shanti Shanti, Shanti. Thank you. God bless you all.
Thank you.
Thank
Thank
you,
you
sir.
once
Thank
again,
you so
Dr.
much.
Sharma.
Thank you, sir. Thank you. Thank you very much.
Thank you. Nice being with you.